Have you ever sat in a passenger seat, staring at a massive wing, and wondered, how does this 200 machine actually stay in the air? It is not magic, and it is not just heroic power. It is a masterclass in structural engineering that has evolved over more than a century. In the next 10 minutes, we are going to strip an airplane down to its bare bone. We will look at the 5 constructions and make flights possible, why they are built the way they are, and why this machine actually is some of the safest engineering marvel ever created. I am Indodico, your favorite YouTube channel without aviation, and this is a beginner guide to how an airplane works. But before we proceed, this video is in 3 different educational sections. Number one of it is the anatomy of flight, that is, the basic structure of an airplane. Number 2, physics in motion, that is, the engineering to how the structure enable flight. Number 3, the secret why it is safe, that is, the hidden details of materials, safeties and risks. Let us dive into the video. The anatomy of flight, that is, the basic structure of an airplane. To understand how a plane flies, we have to look at how it is built. Why every aircraft is unique. Almost every commercial plane you see share the same 5 structural building blocks. Think of these as the skeleton of the aircraft. We have 5 basic structures of an airplane that make it to function properly. Number 1, the fuselage. Number 2, the wings. Number 3, the empennage. Number 4, the powerhouse or engine. Number 5, the landing gear. Let's talk about it one after the other. The fuselage. This is the body of the airplane. It houses the passenger, the flight crew, and the cargo. Its shape isn't just for capacity. It is designed to be aerodynamic, to minimize drag, while cutting through the air. Number 2, the wings. These are the most important part of the structure that generates that lift. They generate the lift that contract the plane weight, but they also the primary fuel tank for most commercial airliners. Number 3, the empennage or the tail. Then, the empennage or the tail is provide stability. You have the vertical stabilizer, which keeps the nose pointing straight, and the horizontal stabilizer, which control the speed, helping the plane to go up or down. Number 4 and 5, which is the engine and the landing gear. Finally, the engine and the landing gear. The engine provides the thrust to overcome drag, and the landing gear, it is the only part of the structure designed to undo the massive impact of meeting the ground. We have talked about the basic structure, which are the fuselage, the wings, the tail, the powerhouse, which is the engine, and the landing gear. Now, knowing this is the basic, but it is how they interact that creates the magical flight. Let us look at how the design of this part actually creates lift. The second section of the video, physics in motion, that is, the engineering to how the structure enables flights. So, we have our airframe, but why does this shape actually lift into the sky? It all comes down to aerodynamic. When air moves over a cold rings, it travels faster over the top than the bottom. This creates lower pressure on top, literally pulling the wings upward. This is the foundation of how the plane flies. But a plane isn't just a killer. It needs to turn, climb, and descend. That is where the control surface comes in. Attached to the wings and the tail are movable parts. Ailerons for banking, elevator for climbing, and the rudder for steering on the ground and in the air. These are the hinges that turn the airframe into a precision machine. When the pilot moves the stick, it isn't just moving metals. It is manipulating airflow to force the plane into a new position. It is a constant high-speed dialogue between the wing structure and the atmosphere. The engineering trade-off. Now you might ask, why are planes made up of what they are made up of? It is the ultimate engineering trade-off. Weight versus strength. We need a structure light enough to get off the ground, but strong enough to withstand the immense G-force of a ton or the turbulence of a ton. This is why modern airplane engineering focuses so much on advanced materials like carbon composites, not just heavy metals. So, we have a body that holds us, wings that lift us, surface that sails us, and material that keep us together. But there is a side to airplane structure that you rarely see, which is the secret to why commercial aviation is incredibly safe, how it actually flies. So, we have our body and our wings, but why does a plane actually lift? Why does a wing actually lift? Think of a wing like a giant invisible ram. Because of its facial curve shape, the air has to push the wing upward as the plane moves forward. That invisible push is what we call lift. It is basically fighting gravity every single second. The plane has a giant puppet. Now, how does a pilot control such a massive things? Think of the plane like a giant sophisticated puppet. On the wings and tail, there are small moving flaps called control surface. When the pilot moves their controls, they aren't actually pushing the plane. They are moving this tiny inch. That changes the airflow around the wings, forces the entire plane to tilt. It is a constant high-speed compensation between the waist and the air. Move an inch, the air moves, and the plane responds. It is surprisingly delicate for something so massive. The big challenge: light but strong. Building this is incredibly hard. You want a structure that is as light as a feather, so it can actually get off the ground, but as strong as a sound, so it does not break during a turbulent storm. Engineers have spent years testing materials to find that perfect balance. This is why you see so many new advanced materials being using modern airplane engineering. They are finding ways to make plane even lighter and stronger. So, we have talked about the anatomy of light, physics in motion, so let us discuss the third educative section of the video, which is the secrets to why it is safe. That is, the hidden details of material, safety and grace. So we have a body that holds us, wings that lift us, an inch that steers us. But there is a hidden side to how an airplane is structured. That is the real secret to why flying is so safe. Let us look at why airplanes are built to survive almost anything. So we have covered the body, the wings, and the control. But there is a final piece to the puzzle. Why doesn't it just break? The truth is, airplane structure is built with redundancy in mind. That is just a fancy way of saying everything is built to handle failure. Flexibility is strength. You have probably seen a plane misplaced during turbulence. It's mystifying, right? But it's actually the opposite. Here the wings were rigid. It will snap under pressure because it is designed to bend. It absorbs the energy of the wings. A plane is essentially designed to breathe with the atmosphere, not fight it. Before a new plane ever carries a single passenger, and do not take it to the breaking point. They naturally bend the wing onto the snap just to see how much force they can take. They push the structure far beyond anything it will ever face in the real world, the big picture. When you look at it this way, an airplane isn't just a collection of metal and plastic, mean the aluminum. It is a highly intelligent flexible system built from the ground, all to take you safe at 30,000 feet above sea level. So, we have actually talked about the anatomy of light. the physics in motion, and why these engines are some of the safest engine armor we ever created. From the fuselage to the landing gear, every single piece of the structure is meticulously designed to handle the force of light and keep you safe at 30,000 feet. It is easy to look at a plane and see just a massive machine, but now you know that it is actually a brilliant flexible system. If you're a beginner, I want to learn more about our plane wars. This is just the start. Subscribe, like and follow, and let me know in the comment section. What is that one part of a plane you have always found most confusing? I will pick the best question to answer in our next deep dive. Thank you for flying with me today. See you in the next soon. Thank you for staying to the end of the video.